You've been mooned. Okay, today we're going to be talking about some different moon facts. It's a pretty amazing body that's been observed for a very long time. A lot of mythology and origin stories and cultural stories about the moon, but it's pretty amazing. It's 240,000 miles from Earth. When we finally actually went to the moon, it took the Apollo missions about 66 hours to get there. So if you do the math, miles per hour, they're going about 3,600 miles per hour on their Saturn V rocket to boost and the different modulars to get there. So long ways away, long time, almost 3 days, pretty close to 3 days to get there. So I wish we had more time, and we may spend time at the end if we do to go over the Apollo missions and stuff. But so the moon is about a quarter the size of Earth, and so the size difference in astronomy, size is everything when it comes to gravity. So it's a quarter the size, but we have about 1/6 of gravity on Earth. And so what does that mean? If you were on the moon, your weight would be 1/6 of what it is on Earth. So want to lose some weight, go to the moon. Quick and easy way to do that. But the larger mass objects, the more gravitational pull on them, and so that's why on Earth you have a higher weight, because the larger mass object would cause you to have a higher weight. Period of rotation. So this is what is known as a day. So it's spinning on its axis. Okay. Period of revolution is called its year, and that's it going around us. It's revolving around us. They are exactly the same, 29 and a half days. So what does that mean? All right. So it creates two basic things for us. We always see the same side of the moon. It wasn't until these Apollo missions that we actually got to see the back side of the moon. And so this model is pretty cool, scale model of the moon. This is the side that we see. So what does that mean? As it is going and rotating, if this was Earth in the center, as it is going and rotating on its axis, period of rotation, and it's going around us, we only see that side, okay? And this creates some pretty cool things for us. If you notice, here's the front side of the moon that we can see, and here's the back side of the moon. Can you guys see the difference in that? All of these are impact craters. And what do you notice about the impact craters on the far side and the side that faces us? Well, I think it's pretty obvious that there's a whole lot more that are here, okay? And so our moon, because of this period of rotation and revolution are the same, we see the same side, but this has also acted as a shield for us. And so if we have meteoroids hurling through space and Earth's gravity pulls those things towards us, the backside of the moon acts as that shield for us. And over the history of the Earth and the moon system, you can see that, a lot of these, our moon has protected us for a very, very long time. We're going to get, in the next video, we'll talk about some implications to it and where they think the moon actually came from. It's a couple different theories. So there's no atmosphere on the moon. So what does that mean? On Earth, we have our atmosphere. And our atmosphere acts as a shield. It also, so if we have things that are coming in Earth's orbit, they can bounce off, they can burn up in that atmosphere. The moon does not have that. And so that's also why there's a lot of impact craters. But atmospheres on planets, they create weather. And I'm sure all of you guys have heard about the greenhouse effect. So if you walk into a greenhouse, that plastic that's on the outside, it traps the heat that's inside and it makes it warm. and it creates weather. So there's uneven heating and cooling on Earth, and that's where we get our weather from. So for the moon to have no atmosphere, that means that there's no weather on the moon. Okay? Now, that doesn't mean that it's not cold and it's not hot, but these temperatures are pretty consistent. So during the daytime, it gets 273 degrees Fahrenheit, and at night it goes negative 244. And so when those our astronauts and the Apollo missions were landing on the moon, during the daytime is when they would do all their missions, and their suits were insulated and protected them from that extreme heat. And at nighttime, they would get back into their capsules, and that's when they would sleep, and that's when they would just get out of that very, very extreme temperature. Now, if you notice, this one doesn't do a great job of showing it, but I'm sure all of you have gone outside and you've noticed, this is another model that I have, that there are dark spots and light spots when you look at the moon at night. If you've never really paid attention to it, I encourage you to grab some binoculars. Just look at the moon and you'll be able to see these things. And so these dark spots, these darker areas, are called maria, and that literally means seas. And these are where old lava flows, as the early moon was solidifying and coming to be. There was tectonic activity that's on the moon, and the Apollo missions, they left sensors, and there are moonquakes that they have detected. And so we know that at one time there were lava flows, and all these dark spots, this maria, is from those lava flows. The lighter spots that are on the moon, these are called the highlands, and these are where these impact craters have created the different features that we would see. Some other interesting facts about the moon: it rises about 55 minutes later each night. This can come to your advantage at different times. So Mr. Thorne and I were elk hunting a few years ago, and I got a bull, and we started processing him and to get that organic, high quality meat off. And I knew from the night before that the moon was going to be coming up, and it was a full moon phase, and so that helped us to have a little bit more light. And so that's kind of a good thing to know. Also, there is frozen water that has been discovered on the South Pole in recent years, and this is why we have the different SpaceX and these people are looking at going back to the moon. They're looking at the moon as being a launching pad for us to go to Mars, and they want to be able to use this water to separate it and get hydrogen fuel from it, potentially mine it and use it not only for drinking, but mainly for another fuel source, so that we can go and explore other parts of space. So